In this video, we will see how to sample data from Monet database, how to collect statistics about our data, how to refresh that statistics, and how to prepare SQL statements. I will first start my server, so I will type MonetDB start, and then I will type folder with my server. And then I will open client application and client. I will log in as a user via C into database via C. And my password is also via C. And now that we are inside, we can create one sample table. So I will create a table with the name sampling table. And this table will have only two columns, column letter and column number. After we have created this table, we will fill our table with some data. So I will run one more statement. And then we can read from our table. So we can type select star from sampling table. And this is how our table looks like. I will now clean my screen. If we want to get a sample of rows from our table, we can use sample clause. But first we have to define the size of our sample. And that size can be defined as a percentage of number of records in our table. For example, this here means that we are going to take 20% of rows from this table as a sample. So when I run this, we would get a result with 2 rows. It is also possible to be specific, to ask exactly for 3 rows. So we want to get exactly 3 rows, and then we can type an argument that is some integer bigger than 0. So we would get then 3 rows. If we use 1 as an argument, in that case we won't get 100% of rows, but we would get only 1 row. It is also possible to use a sample clause inside of our subquery. So we can use it like this. So this will get 10% of rows from our table inside of subquery, and then we can read from that subquery. So if I run this, I would get only 1 row. It is also possible to use sample clause inside of insert into statement. So we can type something like this. This means that we would get 2 rows from our table as a sample, and then we will insert those rows into our table again. So if I run this, this will work, and then we can read from our table, and we will now see 12 rows in our table where 2 rows will be repeated, and those rows are these two, so B2 and J10. I will now clean my screen. We will now see how to read statistics about our data. And for that we have to be administrator, so I will quit this session, and then I will log in again as administrator MonetDB. I will log into database via C, and my password is MonetDB. And now we can read statistics from system table with the name sys.statistics. And we will read only statistics about our sampling table. I will run this, and we can see that the names of tables and columns are all written with small letters, so we have to be careful because of that. And inside of this table we can see column ID, schema name, table name, column name, data type. We can see the size of our column in bytes. We can see approximate number of rows in our columns. This will tell us whether all the values inside of our columns are unique, whether do we have nulls inside of our columns, what is the minimum value and maximum value inside of our column. And I will now clean my screen. If we read data from a system table, we would only see statistics about user tables. If we want to get statistics about system tables, then we should use this function. This function has the same name as a system table, but this is a function. It has these parentheses, and when we run it, we will see all of our schemas and tables, but here we will also find tables from syschema. That is, here we will see system tables. And if we filter this table by syschema, then we would see all of the system tables inside of Monet database. Now this function is even more useful because it accepts some arguments. For example, if we want to get statistics about some schema, in that case, we should provide the name of that schema as an argument. So this is statistics about this VOC schema. We can also provide 2 or 3 arguments. We use 2 arguments if we want to get statistics about some table, or if we want to get statistics about only one column, then we should provide 3 arguments. In that case, we are providing schema name, table name, and column name. Now, all of these statistics inside of this system table is really important because Monet is using that statistics to optimize queries. So these statistics should be always updated in order for our queries to be fast. But after committing many deletes, updates, or inserts, these statistics will become obsolete. So we have to refresh it, and for that we have analyze close. If we type analyze VOC, this will refresh statistics about this schema. We can also type analyze VOC dot sampling table to refresh statistics about this table, or we can use syntax like this one in order to refresh statistics about this column. I will now clean my screen. We are currently logged in as a Monet administrator, and default schema for Monet administrator is sysschema, and I want to change that temporarily. So I will change my current schema to VOC. And now that my current schema is VOC, I don't have to type VOC.sampling table. I just have to type sampling table because Monet now knows that my current schema is VOC. And now we will talk about prepare statement. It looks like this. Here first we have this prepare keyword, and then we have some normal SQL statement. Inside of this normal SQL statement, we don't use any arguments. Instead of that, we are using question marks as placeholders. And the purpose of this statement is to create and cache one execution plan. If we want to execute this statement 1,000 times, so for example, I want to insert many rows inside of this table, each time Monet would calculate a new execution plan, but all of them will be the same. So it is much wiser to create one execution plan and to use it each time. And this is the purpose of prepare statement. So when we run this, we will create our execution plan, and that execution plan will have an ID of 7. Now that ID is important because we will use that ID to call our prepared statement. So we can, for example, call it just 3 times. So I will type this. I will type execute, and then I will provide an ID of my prepare statement, and then we will provide arguments. This letter O will replace this first question mark, and this number 100 will replace this second question mark. So when we run this, we will actually execute our prepared statement with these arguments. And we can repeat this, for example, 3 times. So I will run again similar statement and again, and then we will be able to read from our sampling table to see whether new rows are added. So I will use select star from sampling table, and we will see at the end that now we have 3 new rows, and each of these 3 rows is inserted by using same execution plan. If we want to learn about our prepared statement, then we should read from this system table. So I will run this, and here we can see our prepared statement. Now this prepared statement is valid only for one session, and it can be deleted if we have some error inside of this session. So when we made it, we should then use it immediately. But if we want to delete prepared statements for this system table, in that case we're using deallocate close, deallocate prepare, and then an ID of our prepared statement. So this will delete this row from this system table. It is also possible to use deallocate prepare all. This will delete all of the prepared statements from our session.